So this is the 20th session on relative velocity. So in this session I'll take up another problem on relative velocity one-dimensional collision problem. Fine. Relative velocity one-dimensional collision problem. I'll take up. Okay. Also I'll write down the question. So the question is like this: P1 and P2 are two moving points. P1 and P2 are two moving points, and at time t equal to 0, distance between these 2 points is L. Distance between P1 and P2. Also, acceleration of P1 and P2 with respect to G meaning ground frame, are equal to A rightward arrow and 4A right. Where A is constant, positive constant. Okay. So also P1 is to the left of P2. P1 is initially to the left of P2, and A is a positive real number. Okay. 3 cases are given. So out of 3 given cases, at time t बराबर 0, velocities of P1 and P2 are u1 and u2 respectively. Both P1 and P2 are moving along common line joining them. Fine. So 3 cases are given. First case is this. Initially P1 is here, P1 is to the left of P2. They are separated by a distance L. P1 is moving rightward at a speed 4u, and P2 is moving at a rightward speed u with respect to ground. B, P1 is moving to the left. I'm just saying the question because I forget the data. Okay. Moving left. Okay. And P2 is also moving left, 5u. All these velocities are along the line joining the 2 points. And in part C, P1 is moving at a speed u rightward, and P2 is moving at a speed of 6u leftward. Okay, fine. So this is the situation. Now, in all the 3 cases ABC, to find the view so that P1 and P2 collide. So that P1 and P2 collide. U has to be found in terms of A and L. Okay, U in terms of A and L. In terms of A and L, we have to find. Okay, fine. So this we have to solve using the concept of relative velocity. Fine. So I'll rub it. Okay. Both P1 and P2 are moving along common line joining them. All motions are taking place along common line joining these 2 points. So now what we'll do, that we'll solve this problem using the concept of relative velocity. Fine. We'll solve this problem using the concept of relative velocity. So I take up the problem part A first. See, in all the ABC parts of this question, expression of these 2 points are same as given initially. That is common to all 3 of them. Fine. So first of all, what do? We solve using concept of relative velocity. Fine. using the concept of relative velocity. So now we have two options. We either solve the problem as seen from P1 or we solve the problem as seen from P2. It's up to us, whichever we take. Okay. So I'll solve the problem as seen from P1. Fine. So we'll solve it as seen from P1. That is, we are observing P2 from P1. That is, we are observing P2 from P1. Okay. So now first what we'll do, expressions which are given initially, which are common to all these A, B, C, all three of them. So we'll first find the relative expression of P2 with respect to P1 in ground frame. Fine. So we first find A, P2, P1, G, which is just the relative expression of point P2 with respect to point P1 in ground frame, which is A relative, and which you know is A2G minus A1G, and this we know is A2G and reverse of A1G. We add factorially these two quantities, then we get this. Now A2G is how much? A2G is given to be, as I mentioned just now, A1G is given to be how much? A1G is given to be A right, and A2G is given to be how much? A2G is given to be 4A right. Okay, so A1G is given to be A rightward and A2G is given to be 4A rightward. Fine. So now we find this A relative first. So A relative is the vectors of these two vectors. Now A2G, this is just equal to 4A rightward. A1G is A rightward, so minus A1G is A leftward. Now we have to add factorially these quantities. Vector addition rule said it comes from vector addition rule. This will be 3A rightward. So relative expression of P2 with respect to P1 in ground frame is 3A rightward. Fine. So this is A relative, okay? Constant. Since this is constant, so we can apply the formula for the straight line motion. With respect to P1, P2 is moving along a straight line, join these 2 points. And A relative is constant. So we can apply the formula. V relative square equal to U relative square plus 2A relative into D. This formula we can apply. Fine. Now we have to take up all the 3 cases one by one separately. Fine. So this is common to all A, B, C, all of them. Fine. Alright. Okay. So now we take the part A. Now we take part A of the question. In part A, how much U1 is given? I'll just see the data. I'm forgetting the data. Okay. U1 is just 4U right, and U2 is equal to U right. So we first find this U relative now. So U relative common to all of A, B, C method will be common. A relative will be simply relative expression of P2 with respect to P1 in ground frame, which is simply U2G minus U1G, which is nothing but U2G and reverse of U1G. If we add factorially these 2 quantities, then we get this UP2 P1G. Now in part A, U2G is how much? U2G is given to be U rightward. See, this is U rightward. U1G is given to be 4U leftward. So minus U1G is, this will be 4U leftward. Fine, okay. U2G is equal to U rightward and U1G is equal to 4U leftward. We have to add factorially these 2. So they in opposite direction, this has larger magnitude. So U relative in this case will be 3U leftward. Fine. So A relative is how much? A relative is 3A rightward, constant. U relative is 3U leftward. Now see, U relative is in leftward direction, A relative is in rightward direction, opposite direction. So this will mean that as time advances, V relative speed between these 2 points decreases. Why? Because U relative and A relative are in opposite directions. So as time will advance, V relative will go on decreasing. Okay. So V relative goes on decreasing. Fine. This may mean that when P2 has covered certain distance D with respect to P1, V relative will vanish. So we said V relative equal to 0. And D is the relative displacement of P2 with respect to P1 till that instant. So U relative is, this will write like this. U relative plus 2A relative into D. Now this is 0, U relative. Now we also know that U relative, A relative, D all have to be taken with proper sign. Fine. So with a line of motion, I take the rule that left side is minus plus and right side is minus. So U relative is how much? 3U left, so that is positive. And A relative is how much? 3A rightward, and left I have taken positive. So 3A rightward has, so A relative will be taken to be minus 3 and D. So on solving this, D comes how much? 9U square by 6A, that is 3U square by 2A. Now if these 2 points have to collide, D should exceed L. Because if D is less than L, then there is no question of collision at all. Initial separation L, okay. So D should exceed L. So U should be more than root 2 AL by 3. This is the first part of the answer. So this is U mean for the first part of the answer. For first part of answer, U mean is equal to root under 2 AL by 3. This is U. U mean is equal to root under 2 AL by 3. So if U exceeds this quantity, then the 2 points will subsequently collide in course of their motions. Fine. So this first part of the question has been fully solved. Fine. Now I will add up this, okay. I love all of it, huh? Fine. Now I take the part B of the question. For part B also A relative is same, 3A rightward. That is one time calculation, fine. So part B, U1 is how much? For part B, U1 is equal to U left and U2 is how much? U2 is equal to 5U left. Again we will find what? U relative, okay. So U relative is just equal to initial relative velocity of P2 with respect to P1 in ground frame. This will write as U2G minus U1G. This will just be U2G plus minus of U1G. Now U2G is how much? U2G is equal to 5U leftward. And how much is U1G? U1G is U leftward. So minus U1G will be U rightward. So plus U rightward. Vectors of these two will just be 4U leftward from the rule of vector addition. So in this case also what do we see? A relative is how much? 3A rightward. And U relative is how much? 4U leftward. They are in opposite directions. This means as time will advance, relative speed between P2 and P1 will go on decreasing. So V relative will decrease as time passes by. Yani this will mean that when P2 has covered certain displacement D with respect to P1, V relative will vanish. So we again apply that third formula because A relative is constant. So V0 square equal to U relative square 4U whole square plus 2 times A relative. A relative is minus 3A because leftward is plus and rightward I have taken to be minus. So 2 times minus 3A into D. So on solving this, D will turn out to be 16U square by 6A. That is just equal to 8U square by 3A. In order that these two points collide, D should exceed L. So for collision to take place, D should exceed L. Fine. D should exceed L. Then only collision is possible. Because if D is less than L, then with respect to P1, P2 will come to rest by covering a distance which is less than L. So there is no collision when L is initial separation. So D should exceed L. So 8U square by 3A should exceed L. So U should exceed root 3AL by 8. This is the answer. So this is the minimum value of U in part B of the question. In part B of the question, U minimum is equal to root under 3AL by 8. This is the minimum value of U. Root under 3AL by 8. That is the minimum value of U, so that 2 points collide subsequently in course of their motion. Fine. Now I'll grab it, okay. Now I'll take the part C of the question. Now in part C of the question C, the data is this. P1 U1 is how much in part C? U1 is equal to U rightward, and U2 is how much? U2 is given to be 6U leftward. 6U leftward, okay, fine. Sorry, 6U leftward, and that is U rightward. So again, we have to find the minimum value of U so that the 2 points collide. Method will be same as we solved in part B and A and B. Again, A relative is same, 3A rightward constant. Again, we find U relative. Initial relative velocity between P2 and P1 in ground frame. That is just equal to U2G minus U1G. That is just equal to U2G plus of minus of U1G. So all these relative velocity calculation problems have been discussed in the previous videos. If you just go to the previous videos, you will get all the numericals from these questions also. They also have been discussed fully. So now U2G is how much? U2G is 6U left. And U1G is how much? U right. So minus U1G is also U left. So vectors of these two will be 7U left. So this is U relative. So U relative is 7U left and A relative is 3A right. Since U relative and A relative are in opposite direction, so this means that I'll write it again. Since U relative and A relative are in opposite directions, this will mean as time passes by, upward arrow mean time increasing, relative speed between these 2 points goes on decreasing. Again, since A relative is constant, therefore we can apply this third formula again, which we have been applying for part A and part B. U relative square plus 2A relative into D. So V relative is the relative speed between these 2 points at certain instant. U relative is the initial relative speed, which is 7U leftward. A relative is the constant relative acceleration of P2 with respect to P1, which is 3A rightward. And D is the displacement of P2 with respect to P1, relative displacement. Now, since V relative is decreasing with time, therefore at certain value of D, V relative will vanish. So we say 0 square equal to U relative is simply 7U left. All they have to be taken with sign, leftward sign plus, rightward sign minus. So leftward side, 7U left hai, it is 7U whole square. And A relative is minus 3A because leftward is plus and rightward is minus. And D is just relative displacement of P2 with respect to P1. So D will just be equal to 49U square by 6A. Now in order that the 2 points collide, this should be more than L. So U should be more than root under 6AL by 49. So you should exceed this quantity. Root under 6AL by 49. This is the minimum value of U in part of the C of the question. Fine. So in part C of the question, minimum U should be this much. Root under 6AL by 49. Fine. So this is the 20th session of relative velocity. In 29th and 30th session also, problem on this same type will be discussed, and then we'll pass over to other types of relative velocity problems. Fine. So if you go through all this example, then your relative velocity concepts will be alright, very nice. Okay. And main is that you should know how to find the relative velocity correctly. When 2 points are moving in opposite directions, relative speed is the sum of speeds. When 2 points are moving in opposite direction, same direction, relative speed is the difference in speed. That concept should be clear. Okay. So all these types of relative velocity collision problems have been, relative velocity calculation problems have been discussed in the previous videos also. If you go through them, you will get all the problems there also. Fine. So this all they are all based on the correct calculation of relative velocity and relative acceleration. That is most vital. Okay. So then we close this session just now. So again, I'll take up in next 2 sessions also. I'll take up problems of this same type. Fine. So at the end of it. Okay.